Assalamualaikum. My name Nur Amalia Zafira binti Zahari. My metric number S64321. Today I want to present for subject aquaculture biotechnology. I choose topic for present is type and mechanism of bioremediation in aquaculture waste. First, I want to present for abstract. Increased fish production is being achieved by the expansion of land and water under aquaculture and the use of more intensive and modern farming technology that involve higher uses of inputs such as water, feeding, fertilizer and chemical. Next, as a result, aquaculture is now considered as a potential pollution of the aquatic environment. In this context, bioremediation is more cost-effective and environmental friendly treatment option for many environment pollution. Bioremediation consists of using living organisms such as bacteria, fungi, actinomyces, cyanobacteria, and plants to reduce or eliminate toxic pollution. Next, introduction for this topic is the heterotrophic bacteria degrade or transform organic matter, ammonia, nitrate, and hydrogen sulfide contained in the waste that are released in the aquatic environment. They do it through nitrification, denitrification, and hydrogen sulfide breakdown. Therefore, any successful bioremediation method should aim at optimize the rate of those processes and maximize carbon mineralization. This improves the water quality in aquaculture environment by remove the toxic of the organic matter, decrease the development of the anaerobic condition in the sediment and reduce sludge accumulation. Next, for proper aquaculture waste treatment, it should be necessary to accelerate the biodegradation process by stimulating the microbe grow by accumulating the concentration of microbe. The farmer can be carried out by changing the environmental condition for those most suitable for the growth of the degrades. The latter involve the addition of bacteria culture to enhance the breakdown process. Both of them are the main strategy in bioremediation technique. Next is a bioremediation technique have two. First is a biostimulation, then second is bioaugmentation. First, I want to talk about biostimulation. Biostimulation is the bioremediation strategy by which is the natural occurring microorganism provide which environmental condition that favor their growth and reproduction. The presence of nutrient fertilizers such as nitrogen and phosphorus as well as oxygen boost the capability of the microorganism of breaking down the organic pollution. Next, anaerobic bacteria responsible for oxidized process can only function well in environment with successful oxygen. If these bacteria are provided with artificial aeration, they will rapidly break down toxic ammonia and nitrite to nitrate. Besides add nutrient and oxygen to the microbe, biostimulation can be achieved by provide an artificial substrate which will encourage the natural occurring bacteria to grow and multiply by farming biofilm. Most biostimulation techniques involve crate addition site in which the oxygen diffusion is increased. This stimulation the formation of a biofilm. Next, there are several biostimulation engineering process for biofilm formation which can be utilized in treat aquaculture waste. Biofilter allow the diffusion of oxygen and from addition site for rapidly collecting natural aerobic bacteria involved in the nitrification and denitrification process. Biofilters are commonly used in semi-closed recirculating system to treat aquaculture waste water to be reused. The recirculating system involves recirculating water between a culture facility and a water treatment facility contain the biofilter. The waste is captured in concentration effluent. It is thick to sludge and then decomposed by the bacteria present in the biofilter. The bioremediation efficient of biofilter make the recirculating aquaculture system to be recommended in marine aquaculture system as an effective way of reduce aquaculture wastewater pollution. Next, this is a type of biofilter. First have microbiomelt, then activate sludge trickling filter, then rotate biological contactor, and last is a denitrifying filter. Next, we go through to integrate multi-tropic aquaculture, IMTA. IMTA is a polyculture method of culturing feed species, such as finfish or shrimp, which adhere inorganic extract organism. Several studies have shown that mussel and oyster, when co-cultured with fish, help to reduce the organic matter in the waste effluent. Next, the polyculture help to remove the organic matter as the waste from the feed species, provide nutrient to the extract species. This reduce the amount of waste relief to the environment and balance the ecosystem. Next, microalgae know to treat wastewater by remove inorganic carbon, nutrient, and pathogen and heavy metal. Their incorporation in aquaculture production not only reduce the waste but also increase profit, as they also produce food biomass for other aquatic species. Next, I want to talk about bioaugmentation. Involve the addition of commercial prepared bacterial strain, the addition of a blend of isolate enzyme, or the combination of both the bacterial strain and the enzyme, to increase the natural degradation carried out by the indigenous bacteria population. Okay, now let me explain about bacteria strain. Latest, biotechnology use some bacteria strain that have been genetically modified to increase their stability and survival in the aquatic environment. Actually, the first documentation on the use of bioremediation in aquaculture describe the use of different states of bacillus species in a Pinus monodon farm. In this water, bacteria was first pre-inculate into the rearing water, which diminished the concentration of the ammonia and nitrate, and then increased the shrimp survival. Later on, the bacteria were inculate into the pond in which the adult grow, and then shrimp harvest increased. The last result of this work show the complete remove of all toxic gas present in the pond, which in return improve the water quality, significantly reduce the concentration of vibrant species, and even improve the shrimp's health. Next, we go to enzyme. Bacteria strain capable of biodegradation waste can be genetically engineered to produce the species enzyme suitable for degradation. Direct application of enzyme has more rapid action as they immediately break down the chemical bond. However, enzymes are only limited to enzyme-mediated reaction in which the product are less toxic than the substrate, and in the detoxification process that do not require multi-step pathway. Therefore, the enzyme should be combined with microorganisms for an efficient bioremediation performance. Okay, last I want to explain about combination of bacteria and enzyme. To counter the limitation associated to the use of enzyme, it is necessary to combine them with bacteria strain. The bacteria strain are necessary for fermenting the sludge after enzyme have broken down the large sludge particle, which future create large surface area for an easy bacterial action. This combination of microbe and enzyme ensure the complete reduction of the organic matter. This improve the water quality. A future help in the disease prevention, improve the survival of culture organism, and this increase the farm production yields. In conclusion, the current development of aquaculture industry, more and more waste will be produced, and in return, environment impact from the sector will be continue to rise. The natural function of microorganisms are to interact in aquatic environment, help in design biological remediation method of the treat aquaculture waste. Bioremediation method, which use the biofilm concept, protect the environment through organic breakdown and by reduce waste landfill. Most of the bioremediation method not only biomitigate the aquaculture waste but also improve biodiversity and create economic stability through product diversification, social acceptability, better management practice, and provide environmental service.